In this question, we are given a figure and the length AC, this length AC is given equal to AE. Further, we are given the length AB is equal to AD and the angle BAD is equal to angle EAC. And we need to show the length of BD equals BE. So which is possible if you prove the triangle ABC congruent to triangle ADE. And applying CPCT, we can write BD equals DE. Now we can see that we are given angle BAD is equal to angle EAC, but we need this whole angle, that is angle BAC equals angle EAD. To obtain that required angle, we are going to add angle DAC both sides on this given equation. So adding angle DAC to angle BAD, we get this angle as BAC, and similarly on adding this angle DAC to angle EAC, we get this whole angle, that is EAD. So now in triangle ABC and AED, we can say AB equals AD, that is given, and we have AC equals AE, that is given, and we have proved angle BAC equals angle EAD. Therefore, from side angle side, we can say that the triangle ABC congruent to triangle ADE. And by using the corresponding sides of congruent triangles, we can say that BC equals DE. In this question, we are given P as the midpoint of the line segment AB. Further, we are given D and E are the 2 points on the same side of AB such that angle BAD, so this is angle BAD, is equal to angle ABE. And angle EPA is given equal to angle DPB. And we need to show that triangle DAP is congruent to triangle EPB. And further, we need to prove that the length AD over here is equal to BE. Now what you can observe that we are given this angle APE is equal to angle BPD, but in order to prove the triangle congruent, we need its angle, that is APD equals to angle BPE. So for that, we are going to add angle EPD on both sides of this given equation. So angle EPA plus angle EPD equals angle APD. And similarly, if we add angle EPD to angle BPE, we get this angle EPB. So now in triangle APD and BPE, we can say that AP equals BP, that's given as P is the midpoint of AB. And angle BAD is equal to angle ABE. And we have proved that angle APE is equal to angle BPE. So we can say triangle DAP is congruent to triangle EBP. And from CPCT, we can write the length of AD as equal to EB. In this question, we are given this triangle ABC as a right angle triangle and it's given 90° at C. Further, it is given that M is the midpoint of the hypotenuse AB and this CM is joined and it is produced to point D such that DM is equal to CM. So in the first part, we need to prove triangle AMC is congruent to triangle BMD. Now, in order to prove these two triangles congruent, what we can see that we are given the length AM is equal to BM. Further, we are given DM is equal to CM. And moreover, these two angles are what? Vertically opposite angles. So we can write these two angles as equal. So therefore, we can write these two triangles congruent by SAS. Now in the second part, we have to prove that angle DBC, that is this angle DBC, as 90°. Now since these two triangles are congruent, from CPCT we can write this angle, say 1 is equal to angle 2, As you can see that here D corresponds to C for the other triangle, therefore angle 1 is equal to angle 2. But since these are alternate interior angles with respect to AC and BD, where DC is the transversal, so we can say that BD is parallel to AC. Now since BD is parallel to AC and considering BC as the transversal, we can say that sum of angle ACB plus angle DBC will be 180 degree by co-interior angle property. And since this angle is 90 degree, we can say that angle DBC will be 180 minus 90, that is equal to 90. And in the third part, we need to prove triangle DBC congruent to triangle ACB. So for that, we can say that AC equals BD as they are corresponding parts of congruent triangle. We have the common side BC and angle DBC is equal to angle ACB, that is each 90 degree. So from side angle side, we can say triangle DBC congruent to triangle ACB. In the fourth part, we need to prove CM equals half AB. Now, since triangle DBC is congruent to ACB, we can say that DC equals AB, that's from CPCT. Now, multiplying half both sides, half of DC can be written as CM as DM is equal to MC. So, therefore, CM equals half AB. In this question, we are given ABC as an isosceles triangle with AB equals AC. Further, it says that the side BA is produced to point D such that the length of AD is equal to, and we need to show that the angle BCD, that is this angle, as a right angle. The first thing that we will do is to consider this triangle. Here we are given the side AB of this triangle is equal to AC. So using the isosceles triangle property, we can say angle B is equal to angle ACB. Let's say this angle is 1. So we can say angle B is equal to angle 1. We are given AB equals AC and we are also given this length AB is equal AD. So therefore we can say that AD is equal to AC. Now consider this triangle ACD. We have AD equals AC. So the angles opposite to these two sides, that is angle D, will be equal to this angle ACD, say angle 2. So we can say that the angle 2 is equal to angle D using the isosceles triangle property. Now adding these two equations, we can say that angle B plus angle C is equal to angle 1 plus angle 2, and we can write angle 1 plus angle 2 as angle BCD. Now in triangle BCD, if we apply angle sum property, we can say that angle B plus angle D plus angle BCD equals 180 degree. Now substituting B plus D as angle BCD, we get this as twice angle BCD equals 180 degree. That results to give BCD on transposing 2 to the other side as 90 degree. So this is what we had to prove, that is angle BCD equals 90 degree. In this question, we are given side AB, BC and the median AM of triangle ABC is equal to side PQ, QR and the median of triangle PQR. Now, first of all, you should know what is a median. Median is a line drawn through the midpoint of a side with its opposite vertex. That means here BM is equal to CM. And likewise, since N is the midpoint as Pn is the median, that means N is the midpoint of QR. It means the length of Qn is equal to NR. And we need to prove in the first part that triangle ABM is congruent to triangle PQN. And in the second part, we have to prove that triangle ABC is congruent to triangle PQR. Now in the first part, we will be proving triangle ABM congruent to triangle PQN. So for that, we will be using the concept of median. So we know that the length BC is equal to QR, that is given, and this is given to us that BC is equal to QR. Now on multiplying half on both sides, it will result to give you half of BC is equal to half of QR. Now, as I said that M is the midpoint of BC, so half of BC can be written as BM. So I can replace half of BC as BM, and half of QR, similarly half of QR can be written as QN. So we got BM equals QN, and say if I mark it as equation 1. Now in triangle ABM and PQN, AB equals PQ, that is given, AM equals PN given, and we have proved BM equals QN. Therefore, we can write triangle ABM congruent to PQN. Now, in order to prove the triangle ABC congruent to triangle PQR, we will take AB equals PQ, that is given, BC equals QR, that is given again, and angle B is equal to angle Q from CPCT. And why so? Because we have proved triangle ABM congruent to triangle PQN, so we can write angle B equals angle Q, that is from CPCT. In this question, we are given ABC as an isosceles triangle with AB equals AC, and BE and CF are the altitudes drawn on the equal sides AB and AC. And we need to show that these altitudes, that is BE, is equal to CF. For that, we are going to prove this triangle, that is triangle ABE congruent to triangle ACF. So in triangle ABE and ACF, we can see that we have angle A as common angle. This side AB equals AC, and that is given. We have AB equals AC. And the angle AEB is 90 over here, and angle ACF is 90. So we can say they are equal by each 90 degree. That is AEB is equal to angle AFC, and the reason here is each 90 degree. So we can say that the triangle ABE is congruent to triangle, this is ACF, and that is by angle side. So once these two triangles are congruent, we can say that the altitude BE is equal to CF, that's from CPCT. So we can say that BE equals CF, and that is from corresponding parts of congruent triangles. In this question, he says BE and CF are two equal altitudes of a triangle ABC. So what we can do is to make a triangle, and I name this triangle as ABC. And we'll make two equal altitudes. Well, the altitude is, one is BE and the other is drawn from C. So this is CF. So this is BE is one altitude and this is CF. Well, altitude make an angle of 90 degree with the base. So this is what we should write. So it says using RHS congruence rule, we need to prove that triangle ABC is an isosceles triangle. So in order to prove ABC as an isosceles triangle, we need to prove AB equals AC, but then by using the RHS congruency rule. So for that, we are going to consider these two triangles. One is BCF and the other triangle is BCE. As we have to use RHS, else we could have considered the other two triangles. So in triangle BFC and CEB, angle BFC equals angle BEC, that's by each 90 degree. And BC equals BC, that's by common hypotenuse. So we know that the side opposite to 90 degrees is the hypotenuse. Like here, this angle is 90 degree and the side opposite to this angle is BC. That's why we say BC is the hypotenuse and it is common for both the triangle. That's why we say it's a common hypotenuse. And we are given BE equals CF. So you can write BE equals CF. So here you can see that we have taken one right angle, that is R, and then the hypotenuse, which is H, and the side S. So we can say that the triangle is congruent by RHS. So we'll write triangle BFC congruent to CEB. Now once we have proved the two triangle congruent, we can write angle B equals angle C. That's by corresponding parts of congruent triangles. So we'll write angle B equals angle C by CPCT. Now look into this triangle. Let me erase these parts only. So we have proved angle B equals angle C. And what we know that in a triangle, if we have a triangle that is triangle ABC, in a triangle, when two angles are equal, then we have proved these two angles equal. So we can write their opposite sides, that is AB equals AC, that is from isosceles triangle property. So therefore, we can say now, since we have proved two sides equal, we can say that ABC is an isosceles triangle. In this question, it says that ABC and DBC are two isosceles triangles drawn on the same base BC. So yes, it is clear that we have one triangle as ABC and the other triangle as DBC. This is, both of them are isosceles triangle. So they have the same base BC. It implies that AB equals AC for this triangle and BD equals DC. So we should understand that base is not equal to any of its sides. So if BC is the base, that implies BD equals DC. And for the other triangles, again, BC is the base. So we can say that AB equals AC. And they're on the same base. Now, further it said if AD is extended to intersect BC at P. So this AD, the line AD in this case, is extended to meet the base at point P. Now, in the first part, we need to prove triangle ABD is congruent to triangle ACD. So, in triangle ABD and ACD, we have AB equals AC, that is given, and even BD equals DC. These two things are given here. And we have the common side AD. AD equals AD, that's by common side. So therefore, we can write these two triangles, that is triangle ABD, as congruent to triangle ACD. Now in the second part, we need to prove triangle ABP, this triangle congruent to triangle ACP. So in triangle ABP and ACP, we have AB equals AC, that is given, and AP being the common side, AP equals AP, that is common. And what we know that here we can write this angle, say 1 is equal to angle 2. That's from CPCT because these are parts of congruent triangles. As we have proved these two triangles, this triangle that is ABD congruent to triangle ACD. So we can write their corresponding angle, that is angle 1 equals angle 2. So that we can write from CPCT, that is angle 1 is equal to angle 2, and this is by CPCT. So now we can write these two triangles as congruent, that is triangle ABP as congruent to triangle ACP, and this is by side angle side, while the previous one by SSS. In the next, that is the third part, it says AB bisects angle A as well as angle D. Well, it bisects angle, that is AP is bisecting angle A. That means we need to prove angle 1 is equal to angle 2, which we have already proved, or we can write simply from CPCT. But then in order to prove that this line AP bisects angle D as well, we need to prove these two angles, right? We need to prove these two angles equal, and this is only possible if we prove these two triangles congruent. So let's prove this triangle congruent. So in triangle BPD and CPD, we have BD equals DC, that is given, and we have DP as common. DP equals DP, that is common. And what you know that here, that is this side BP equals PC, that is from CPCT. We have proved the two triangles. Let me explain you. We have proved this triangle congruent to this triangle. So we can write from CPCT that this BP equals PC, that is corresponding parts of congruent triangle. So we'll write BP equals PC, and the reason is CPCT. And once we are done, we can straight away write the triangles being congruent, that is triangle BPD is congruent to triangle CPD. And this time it is congruent by the property, that is we have used side, that is SSS. So once these two triangles are congruent, we can write angle 3 is equal to angle 4, that's from CPCT. So now since angle 1 is equal to angle 2, so that means AP bisects angle A, and when 3 is equal to 4, it implies AP bisects angle D. So you may write here that once you have proved, you can write since angle 1 is equal to angle 2 and angle 3 is equal to angle 4, therefore you have to write down this line that AP bisects angle A as well as angle D. Now in the last and the final part, we need to show that AP is the perpendicular bisector of BC. So what does it mean? Well, bisector, ignore the word perpendicular. We have already proved AP. We have already proved AP is the bisector of BC. As you can see that we have proved BP equals PC, right? That means AP is bisecting the BC. So this part is already proved, that is BP is equal to PC. Yeah, it's over here, right? But then we have to prove this perpendicular as well. That means we need to prove one of these angle as 90 degree. So what we are going to do here is to, let's say, write this angle as 5 and this as 6. So we can write angle 5 is equal to angle 6, and that is from CPCT, as these are corresponding angles of congruent triangles. Further, what you can observe that this is a straight line, right? This being a straight line, so we know that sum of all angles around a point is 180 degree, that is from linear pair. So we'll be writing angle 5 plus angle 6 equal 180 degree by linear pair. I can replace 5 with 6 or 6 with 5 as they are equal. So let's say if I replace 6 with 5, so it is 5 plus 5, that is 2 times angle 5 equals 180 degree. That implies angle 5 is equal to 90 degree. So since this is 90 degree, so we can say that AP is perpendicular to BC. So this is the final part. Well, you need to write down this statement. Over here you will write AP is perpendicular to BC, and then you will also write BP is equal to PC from these two equations. If I mark this as, say, this as equation 1 and this as equation 2, then you need to write from 1 and 2 AP is the perpendicular bisector of BC.